We'll start with the first process. Once the sewage is taken to the sewage treatment plant, initially it is subjected to comminutors and macerators. So the first reading will be the same. Comminutors and macerators. So initially, or we can say they are installed. These comminutors and macerators, they are installed before the screenings. Okay, so before the screening process, it is installed. What is the main purpose? So they shred the materials into the size of 7 to 20 mm. Okay, so whatever the materials are there in the sewage, they get shredded with the help of these comminutors and macerators. So these comminutors. So for shredding the materials, this has a cutting teeth. Okay, so this machine has a cutting teeth, and when we talk about macerators, they have grinding wheel. They have a grinding wheel. So with the help of these two, there is shredding of material into the size of 7 to 20 mm, and this is the first stage of the sewage treatment. Okay, now once the material is shredded, now it goes to the next method or the next treatment process, and that is screening. So we have already seen this screening process. So the main objective, we can say the objective of this process is to remove large floating objects. Large floating objects. Now what do you mean by large floating objects? So write down, such as paper, cloth, wooden pieces, glass bottles, etc. Okay, so it is used to remove these large subjects from the sewage. So if they are not removed, what it will happen? It will choke the subsequent operational equipments. Okay, so whatever the pumps are there, whatever the pipes are there present for this in the subsequent treatment processes, they can get choked with the help of these large floating objects. So if they are not removed, they can choke the pumps and pipes in the subsequent operation. In the subsequent operations. Okay. So this screen has, or we can say screen is a device which is having uniform openings with the help of parallel rods. So if I just draw it here, so there are uniform openings in the screen with the help of parallel rods. So these are parallel rods here, and due to this rod, there is an opening which is present. Okay, these are parallel rods. Screens are provided at an inclination of inclination of 30 degrees to 70 degrees with respect to horizontal. Okay. Now the last point about this is classification of screens based on the size. So it is classified into three types. The first one is coarse screen. Second one is called as medium screen, and the last one is called as fine screen. So the openings or size of openings in the coarse screen, it is greater than 50 mm. In medium screen it is 6 to 40 mm, and in fine screen it is less than 6 mm. So based on the size of openings, the screens are classified into these three categories. Now how to design this, or what are the design parameters required for the screens? So write down design of screens. So these screens are designed based on approach velocity, based on approach velocity. So what do you mean by approach velocity? So we'll take an example here. Let's say this is a sewage which is flowing, and this is the bottom surface of the channel. Now what we are doing, we are placing here one screen. Okay, so this is a screen now, and this screen has this parallel rods. Now the initial head of the water is capital H, and the water is flowing with a velocity Va. This velocity with which the water is coming on the screen, it is called as an approach velocity. Okay, and this is our screen. So when the water passes through the screen, due to the obstruction provided, there is a head loss. So the final head is, we'll name it as H dash. Okay, so this height of the water after the water gets after the sewage gets transferred from the screens is H dash, and the final velocity, we'll name it as Vs. Okay, so this velocity is called as velocity through opening of the bar screen or opening of the screen. So for the design purposes here, the first thing that will require is cross section area of screen. So cross sectional area of screen, it can be calculated as B into H, and in terms of discharge velocity we can calculate it as Q divided by approach velocity. So with the help of this we can calculate the cross sectional area of screen. So the approach velocity for design that we will take, approach velocity for design. So this will be taken from 0.6 meter per second, 0.6 meter per second to 1.2 meter per second. If we assume depth, if we assume the depth h, so these values are given in the code as 0.9 meter to 1.1 meter. So you have to assume some value in between this. So if we know all these values and if we assume these required values, we can calculate the width of the screen. Width of screen, that is B. So this B can be calculated by cross sectional area cross sectional area divided by h value. Okay, that is the initial head. So here I'm drawing the screen now. So in this screen, these are the bars that are present. So, so with the use of these bars only, this screen is made. With the help of these bars only, the screen is made. So this is the screen. Now the total width here is B and the total depth is H. So this is our screens. Okay. Now, so these are bars. These are bars with diameter 5. With diameter 5. And the distance between these bars, subsequent bars, is constant, and this distance we are calling it as spacing of bars. Okay, so this s is a constant value and this s means spacing of bar. Spacing of bar. Let's denote n as number of openings. So if n is equal to number of openings and phi is the diameter and s is the spacing, then if we want to calculate the total width, that is b value, so this b value will be equal to n multiplied by, that is n means number of openings. So how many openings are present? 1, 2, 3 and 4. So 4 times the s value, n into s, plus n plus 1 times the diameter value. So if you just look it carefully, if you want to understand how this equation came, see there are these two bars. So I am drawing the bars now in bigger one. Okay, so I am drawing it like this. So this s distance, it is the distance, or we can say it is a clear distance. So from the end parts of the bar we are taking the distance. But however, between these two bars there is certain distance here. You can see. So this distance is half of the diameter. Okay. So this distance is half of the diameter. So for the last bars which are present here, so there will be this half of the diameter and half of the diameter value will be there, and the remaining numbers are the numbers which are present in between this. So there are total 3 numbers and plus half and half, that will be 4. So to reduce that calculations, directly we can, or you can directly write the formula which is given here. Okay. So B is equal to ns plus n plus 1 into 5, where B is the width of the screen, n is the number of opening, s is the spacing of the bar, and phi is the diameter of the bar. So with this we will get the number of bars. Now after this, there is one more formula in this screening, and that is the head loss through the screen. So this head loss through the screen value, h small h, it is calculated as 0.0729 in bracket v, in bracket vs square minus vs square. Okay, where H is the value of head loss. H is the value of head loss through screen. This is in meter. So what is the head loss? So you can see the initial head is H here and the final head is H dash. So the total head which is present, which was present initially, it is reduced now. So the amount by which it is reduced, it is called as head loss. So it is the small h value. So this is head loss. Then Vs is called as velocity. Velocity through the opening. Through the opening of screen. And Va is called as approach velocity. So these values you have to substitute in meter per second. And the head loss you will get in meter if you will substitute all the values in this equation. Okay. So these are all the formulas that are required for the design of the screens. When you will solve the numericals on this, you will get a better idea about how to design. Okay. So but MCQ point of view, this head loss equation is important. And what are the various sizes of openings based on the type of screen, whether it is a coarse screen, medium screen or fine screen. You should understand or you should remember what is the size of openings that is present. Okay. So with this, screening is completed.